Everybody cool? Right? Now, these are really difficult to put on a graph, yeah? Unless you do what? Use your calculator and get the approximate answer, yes? Everybody good? Okay. A rectangle has a perimeter of 70 and an area of 264. Find the length and width. Well, I better draw that rectangle, yeah? WL. What do I know about that rectangle? Perimeter is 70, so L plus W is 35, right? Everybody cool? And what else do I know? L times W is 264. Everybody cool there? Yeah? Okay. Now, how are we going to solve this? This is the very last unit of grade 10 for those of you that were in my grade 10 class. Do I have two variables? There is technically there only needs to be one, doesn't there, Lucas? Because here, I can make that L equals what? 35 minus W, right? Now, if L equals 35 minus W, what can I write right there? 35 minus W times what? W equals 264, correct? Everybody understand? Now, of course, this is easy to solve. W squared, right? 35W minus W squared equals 264. And that's easy to solve, correct? 0 equals W squared minus 35W plus 264. Everybody cool? Now what would we do? Can we try to factor it? Can we? We could, but that's a pretty big number, yeah? Factoring might not be the best move. Could I complete the square? I could, but that would mean we'd have to divide 35 by 2, and 35 is not an even number, so we're going to get into decimals. Blech. So what should we use? Quadratic formula. 35 plus or minus the square root of 35 squared, which is 1,225, minus 4 times A, which is 1, 264, right? Over 2 times 1, which is 2. Simplify. 35 plus or minus the square root of 4 times 264 is 800, 1040, 1,056, right? 1225 minus 1,056, 64 over 2. Does 64 have a square root? 8. So it's 35 plus or minus 8 over 2, correct? Everybody happy with that? Yeah. Okay. What's 35 plus 8? 43 over 2. And what's 35 minus 8? 28 over 2, which is 14. What does that give me? L or W? Now, let's check and make sure all that is right. Yeah, this is not 64. That's 169, so that's 13. So that's 48 divided by 2, which is 24, or 22 divided by 2, which is 11. Does that work? Yes. Because that gives me my two roots. 24 times 11 is 264. Everybody cool? All right. 169. Everybody good? Okay, number 4. It's almost the same question, yes? So we're going to do 4. 16, 23. If the length is decreased by x, which of those have you been taught is the length? 23, right? So 23 minus x, yeah? And the width is increased by x, 16 plus x. The new area, length times width, is 378. What do I do to solve it? Multiply it out, get a quadratic equation, and solve it. So 23 times 16, which I can't be bothered to do in my head today. 368 plus 23x minus 16x is plus 7x minus x squared equals 378, correct? Move it around. X squared minus 7x plus 10 equals 0, yes? Now, what are our options here? We can do one of 3 things. What are they? Factor, or complete the square, or quadratic formula. Which one will always work? Quadratic formula. But it's a lot of extra writing if we don't need it. Do we need it here? No. Why? Because it's easy to factor. What does that factor to? What? Negative 5 and negative 2. So x equals negative 5. Sorry. X minus 5, x minus 2 equals 0. So what are my answers? 5 and 2. X can equal 5 and 2. Now, let's check. 23 minus 5 is what? 23 minus 5? 18. 16 plus 5 is 18 times 21, 378. Yeah, so 5 works. 21 and 18, does that work? Does that work? It's the same thing, right? So we're good. So if x is 5 and 2, right? What is the new rectangle? $18 and 21. Everybody good? All right, now, I didn't want you to do 5. Listen to me, please. If you have a graphing calculator, you do not need to get a graphing calculator. All right? Some of you already have these. Even though the ones the school has look different, they function the same way. All right? Listen to me. I want you all to have one of these for today. All right? But they cost $150 each. I do not want you to leave with them. Does everybody understand? In the past, I used to ask kids to leave me a shoe. They would walk out without a shoe with the calculator. It has happened numerous times. Then I changed. I said, leave me your phone. Guess how many people leave without their phone? A lot. None. No. Not one. You kids are so addicted to your phone, you will remember your phone before your shoe. You will walk out of here with one shoe on. But going 5 feet away from your phone, something's not right. Something's off in the universe. I can see both my hands. There's nothing in them. What's wrong? I don't know. I'm walking in circles, and my right foot keeps stepping on sharp things, and it hurts. I don't know. I'm just going to class. See you there. Come and get a calculator. Leave your phone. kind of teenager in North America in the 21st century doesn't carry a phone?
It's being fixed right now.
Ah, of course, it's being fixed. Yeah. So you do have a phone, you just don't have a phone. All right. Yeah, make it quick. What the hell? Leave a shoe. You might remember your shoe. I'm just joking, Parneen. My favorite thing is when half these people forget to turn their phone off and you start getting texts, which proves to me how little you guys actually do work in this class. When I sit here and hear buzz, 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 all through class time. That's a slick move. Now when someone finds it, they'll see the 20 and they'll pick it up. Because I assume it's not a real 20. It's on the case, isn't it? Yeah. That's a smart move. That's kind of like when you make a sidewalk and you stick a loonie into the concrete so people walk. Oh, there's the first Buddha boop. Where are you? Are you okay? I'm in science class not doing my work. Shouldn't you be in math not doing yours? Respond. Where are you? Oh my God. Oh wait. OMG. At least walk by my class IRL so I know you're okay. All right. What about that is ugly? 4.9. Barf-tastic. Because that means our A is a decimal. Yes? So, we are perfectly capable. H equals negative, or what was it? I can't remember. H equals 2 plus 14t minus 4.9t squared. Now, the only difference between this and what you already know how to do is the order and that it's a t instead of an x, yes? Otherwise, it's exactly the same thing. Agreed? Yeah? Okay. Now, h is height, t is time, right? So if I was going to draw a graph of this situation, I would throw the ball, and that would be at 0 time, yes? And the ball would have no height. Everyone agree? The ball would have a little bit of height because I'm throwing it. Is everybody cool? When I throw the ball, what starts happening to time? It starts going up. What starts happening to the height? I'm throwing the ball. I will demonstrate. Ball. What happened? The ball went up in height to a peak and then what?
Went down.
Went down. So, it looks like this. Everyone agree? Now, what is the point happening right there? It's in my hand. That's why it's not on the ground, because it is off the ground, yes? When I throw the ball, it is going to go up, fall past my hand, and hit the ground, yes? Everyone agree? So, what is being measured down here? Time. What is being measured here? Height. This point right there has what height? 0. And what is the time? Do you know? No, it is time with a height of 0. Does everybody understand? Now, up till now, we've been using x's and y's, yes? So this, if we weren't describing a real-life situation, wouldn't be time and height of 0. It would be x and a y of 0, wouldn't it? And this you have been told, is what is called a root of this equation. Everybody's good? We have been finding those roots using the quadratic formula, yes? Now, in the quadratic formula, which of these is A? The 4.9. What's B? 14. What's C? 2. And if we were going to do the quadratic formula, it would look like this. Negative 14 plus or minus the square root of 196 minus 4 times negative 4.9 times 2 over 2 times negative 4.9. Yes? Blech. We would do all that work and we would get 2 answers, wouldn't we? One of those answers would be positive, yes? And the other one would be negative. Why don't we count it? Because I cannot throw a ball back in time, no matter how fast I throw it. Even if I can throw it 88 miles an hour and it has a flux capacitor in it. I cannot throw a ball back in time. Is everybody good? And you could all do that on your calculator, couldn't you? But if you're going to do that on your calculator anyway, you might as well learn to do it on the fancy schmancy calculator. Cool? All right. Everybody observe. Clear off your calculator, turn it on so you're looking at a blank screen. Now, if you have the older version, the TI-83, and we all have TI-84s, it still works the same. It will just look very slightly different. Okay? Okay. We are going to graph this. Everybody push the button right there that says y equals. Now, the letter y is the vertical axis, yes? What variable, independent or dependent, do I graph on the y-axis? The dependent variable, right? So in this case, it's height, yeah? I'm just going to do this. Give me a moment here, ladies and gentlemen, so I can have my calculator and my drawing in front of me. Everyone is cool? So this is y. So what does that make this? H equals y. What does that make this? Y equals. Now, what goes on the x-axis? T for time. So t equals x. So what are both of these? They are x's. Is everybody cool? No matter what the variables are in the question, on your calculator, they have to be y and x. Yeah? Okay. Let's enter this right here. 2 plus 14. Now, we need a variable. Everybody look at that button right there. X, T, theta, N. Everybody see it? That button is your independent variable button. No matter what letter it is in the question, in this case it's T, on your calculator, because your calculator doesn't know if you're working with height and time, or time and money, or whatever. So it uses y's and x. Everybody cool? Minus 4.9. Now, I have another variable there, yes? So what do I have to hit over here? The variable button, and then I'm going to hit x squared. Everybody should be looking at that. Yes? Has everybody entered that? Now, see how this little equal sign is highlighted? That means my calculator is going to graph that line. Sometimes I may put on more lines on the graph. Every time I highlight an equal sign, I get that line on the graph. We only need one line on the graph right now. This line. Everybody good? Now, something weird is going to happen now. Not everybody's calculator is going to do the same thing because a great many of your calculators have old programming stored in them because we did not reset them, did we? Okay, so everybody hit the button graph. Now, all of you should see something that looks like this. An up and a down. Now, wait. You might not. If you do not see your entire curve, we're going to fix that right now. All right? Everybody hit the button window. So everybody should be looking at this now, yes? Now, do we need any negative values on this equation in real life? No, because we cannot have negative time, and I cannot throw the ball so hard that it drills into the earth, can I? So do I need any t values lower than 0? No. So do I need any x values lower than 0? No. But we are going to keep them for what I'm about to teach you to do. So we are going to say our x minimum is -2. Please make sure you use the negative button, not the minus button. They are different. Negative is down here under 3. So we are going to make that -2. Everybody cool? Then we're going to leave the x maximum at 10. That means we have 10 seconds of this. Everybody good? We actually have 12 seconds because we're at -2, but 10 seconds of real time. Everybody okay? Now, our x scale, that is what each dot on the graph is worth. So we are going to say our x scale is 1. So every dot on the graph, when we go back to our picture, is worth 1. All right? Everybody good? Okay. Our y minimum. Do I need to go down to -10? No. But I want to have a little bit of wiggle room, so I'm going to make it -2 as well. And our maximum, we don't know how high I can throw this ball, yes? So let's make it 25. Is everybody cool? Now, if I leave the y scale at 1, how many vertical dots are going to be on my graph right now? 25. That's a lot, right? It will squeeze very tightly into the graph, won't it? We don't want that. So let's make our y scale 5. That means each dot is worth how much? 5. Is everybody cool? Now hit graph. Can I see my whole curve? Is everybody with me? All right. Now from that curve, I can tell a lot of stuff, can't I? Right there is what? The top of the curve, yes? What does that tell me? The highest I threw it and how long it took to get there, yes? Everybody agree? Okay. It also will tell me where I started throwing it from, the height I started, yes? Because it has 0 time. And it will tell me when the ball hits the ground. Everybody cool? All right. Now, what do I wish to know? What does the question ask you to tell me? How long the ball is in the air. So we need to know at what time the ball has 0 height, correct? Yeah. Which is the point where x and 0 exist, right? Where is the only place on my graph where x and 0 exist? Right there. Agreed? And we know that is the root, correct? Yeah. So let's find the root. Our calculator will do this for us. Let's learn. look at the buttons up there because these are all your graphing buttons. I am trying to find an answer. Please notice in blue on my one, and in yellow, if you have an old one, right above the word trace, it says calc, yes? Calc is short for calculate. Are we trying to calculate something from this graph? Yes. So we are going to push second, calc. And now you're looking at this. Everybody's looking at this screen now, yeah? Use your brain. What one of those 7 options do you think we are interested in? We could be interested in a value. 0. We could also be, that doesn't say intercept. Look at it closer, Burke. Intersect. But it is an intersection, isn't it? It's where the curve crosses the x-axis, right? So it's also an intersect. Oh, did you? I'm sorry, Burke. I misheard you. No problem. I'm saying you're right anyway. No need to be furious. I'm saying you're correct. I can rewind it and prove it to you if you need. All of those 3 things would help us. Now, don't do anything right now. If I push 1 for value, which was what Jazz thought, x equals, oh, wait a minute, I can't do that, can I? Because it's the x that I don't know. So I can't use value. Damn. Nobody pushed value, right? Because I told you not to push a thing. So I'm going back to calc. So it can't be value, right? Does 0 make sense? I have a 0, don't I? So maybe 0 will work. 2. Oh, weird. It's all over the place. Okay. Let's go back to calc. And the other guess was intersect. First curve. Weird. So, both things looked strange. Let's start with the 0. Left bound. What might that be short for? Left bound. We all know what left means. What does left mean? On the left. What do you think bound is? That's a bounce. What might the word bound be? If you are out of bounds, what are you? You're out of the boundaries, yes? So the left bound is what? A left boundary that you care about. Now, please notice, I can see that my curve is right here, right? Use the arrow keys. Push to the left until you see that cursor right there. Keep pushing left until you have x equals 2.46. Left until you have x equals 2.46. Has everybody been able to do that? Yeah. So all of you right now should be looking at this flashing cursor to the left of the number we care about, right? Is everybody doing that? Yeah. Damaris, do you have a curve?
I can get to, I can put my equation in, but it won't let me.
Then why are you just telling me now? Everybody can see that, right? Everybody has x equals 2.46. flashing cursor, yes? Is that flashing cursor left of the point that we care about? Is it?
I don't have the equation up here.
Right? We know this is the point where it's going to cross the axis, right? Is my cursor left of that point? Is it? So it's where we want it, correct? So everybody push enter. Now what does it say on the screen? Right boundary. Now I need to set my boundary to the right of the point that I care about. Agreed? So I'm going to push right. Now watch. Look at my y values. I am looking for the spot where y hits 0, yes? So I must need to keep pushing right until y is what?
0.
Or 0 or negative. Is y negative now? So I have now gone to the right of the point where that curve crosses. Does everyone agree? Does everybody understand what I have done? So I now have a right boundary that is appropriate. Yes, Keegan?
Mine's the second curve instead.
Then you went to intersect, not to 0. So just go second, calc, 0, and do all this. Now, do I have my right boundary? Yes or no? Yes. So I'm going to hit enter. Now, what does your calculator say here? Why is it a guess? Why is it going to be guessing? Close. Does this give me an exact number? Or is this going to give me a crazy decimal? Crazy decimal. Is that crazy decimal an exact number? Which means it is what? A guess, isn't it? So our calculator is saying, you want me to guess here? And what do we want it to do? We want it to guess. So we're going to hit enter.
What if you say no, I don't want you to guess?
Now, look. When our y value is 0, our x value is that. So how many seconds was the ball in the air? 2.99. Does everybody understand? Everybody cool? Everybody should have been able to make this show. Well, that's left boundary, enter. Right boundary, it's now negative, enter. Guess, enter.
Oh, okay. Thank you.
Okay? Is everybody good?
Yeah.
Where did you screw up? So fix it. Second, calc, 0. Left boundary, right boundary, enter, enter, enter. 0. No, dude, the one that says 0. Is everybody good? Jordan. Then you screwed up somewhere. We're going to go through it again. All right, now, stop for a moment. We know this is 2.99, don't we? Okay, now look at this. Don't bother to do this, just look. Right here, yeah? This is negative 14. Oops, clear. This in here, right here, is 196.6 minus 4 times negative 4.9 times 2. Everyone agrees? 235.2 in there, yes? Everyone's cool? Square root 235.2, my last answer, is that, yes? Everyone cool? Right? Now, I'm going to add that to negative 14. Which gives me that. Yes? And I'm going to divide that by negative 9.8, because that's what's down here, yes? And I get a negative number. Agreed? So that says that would be a negative time, wouldn't it? So that's garbage. Negative 0.13 seconds. How can I throw it backwards in time? So it must be plus, right? Or minus 15.33, because that's right there, yeah? Minus negative 14, right? Divided by, oh wait, what did I do wrong? Where did I screw it up? $29.3. I screwed up somewhere in all my work, but it's going to be divided by 9.8, right? There's my 2.99. So I can do this and get the same value. Everybody good? Now I want you to practice this a little bit today because it's a short day. I don't want to go too crazy. Let's go to this question right here. It's on the same page. Don't go anywhere. We already know this answer is 5 and 2, don't we? Right? Punch that into your calculator. So go to graph, go to y equals. Do we want this equation anymore? So we're going to clear it off, and we're going to enter this equation. How do I do that? What do I hit for that? I hit the variable button, then I square it. Minus 7, variable button. Plus 10. Everybody good? And then I'm going to graph it. Now something weird's going to happen. Because remember, our window is set up from the last question we did, isn't it? So since I can't see everything I want to see, I got to change the window, don't I? Or can I see everything I need to see? What do I care about? I care about the x values, don't I? Can I see them? Are they visible? Yeah, so do I need to change the window? If I can see the values, do I need to change the window? No. I want to check those values. And those values are x's, aren't they? So, second, calc. I want my zeros, yes? Left boundary, right boundary. So I want the left boundary. So I use till I get my cursor to the left of one of those zeros. Now please notice something weird has happened, yes? All this writing is covering what I care about, isn't it? That's a pain, right? Everyone agrees? So even though my window looks fine on a graph, I can't use it very well, can I? So, do I need this graph to go all the way up to y equals 25? So what would happen if I change my window? What there should I change? I should change the y maximum to what? Does it matter? What could I put there? I could put anything lower than 25, couldn't I? If I make it 10, and I leave that scale at 5, how many y dots will there be now? 2. Graph that. Now I got a little more space to work with, don't I? But it's still going to get covered, isn't it? Second, calc, 0. Still covered, right? So I'm going to change my window some more. I'm going to make my y max 1. My y scale 1. And graph it. Now am I in business? Can I see my two x's nicely? Is it going to be in the way of the work? Is it in the way of the work? Nope. So let's go. I want my left boundary. I care about these two spots, yes? Does it matter which one I work first? No. So I'm going to move to the left of one of those spots. Where's my cursor? Here it comes. Am I to the left of the point I care about? So I hit enter. Now I need the right boundary. Is my cursor now to the right of where I care about? So I hit enter. Now it's going to ask me, do you want me to guess? Do we? X equals 2. Hey, x equals 2. Everybody cool? Now you do the same thing over here. Second, calc, 0. Now, right now, look at what I can do. Am I to the left of this one? Am I? I'm also the left of this one, aren't I? Well, since I'm left of the one I want, what happens if I hit enter? Okay, there's my left boundary. Now where should I go? If I come all the way over to here, now, do I have both of my zeros in between my boundaries? What do you think's going to happen? I'm going to ask it to guess. It gave me the bigger one. Everybody cool? Which? 5, right there. Does everybody feel they could use the calculator a little bit? We're going to use it more later. Yeah. Everybody feel they could use it a bit? All right, we don't have much longer in class. We're going to just practice with the calculator a bit right now. Your assignment tonight is, I want you to do page 84 and 85. Tomorrow you are writing a cumulative, actually you're right, you got a 4-day weekend. 84 to 87, I think it is. Your cumulative is tomorrow. So this will give you something to work on if you finish it early. Now, go back, ladies and gentlemen, and choose a couple of equations that we've already done, that we already know the answer to, and see if you can make them work on your calculator. Everybody understand? I will be walking around and helping. Yeah. Everybody okay? Monday. 84 to 87 is due Monday. Mm-hmm.
I'm not going to come to school tomorrow.
Okay.
So what should I do?
What do you mean what you do? You're going to miss a cumulative. So you're going to have to come and write it on your own time.
Okay.
You guys could both make the graphs work?
Yeah.
First try?
Yeah, we got Caleb's calculator. Calculator.
Caleb's calculator is the same. Oh, I see. I understand. Yes, you've been too long without your phones. I know. How are you able to live? Yes. So, try a few of these. If you are not able, for example, the rectangle question, you know the answers are 24 and 11. Try to punch it in. Try to move the window around so you can see it. And try to find the zeros. Okay? And everybody else, you can work on 84 to 87. think I'm done recording.